Hi, I'm Ruth Murphy, the Chemistry Lab Manager here at Sutherland Scientific. Today we're going to discuss why we test for the parameters in the standard drinking water tests that we offer to households with private and public drinking water supplies. Why do we test for pH? Since metals dissolve readily in acidic water, dissolved metals may be present in drinking water with a low pH level. Metals such as iron, manganese, copper and lead can leach into drinking water from pipes of the local aquifer. Alkaline or hard water contains excess calcium and other minerals that cause the familiar scaly deposits on cookware and a bitter taste in coffee. Why do we test for ammonia? Ammonia and water can cause corrosion of copper pipes and fittings, causing stains on clothes and towels. The presence of ammonium in water supplies indicates contamination from agricultural or industrial practices as well as sewage systems. Why do we test for nitrites? Swallowing high amounts of nitrate and/or nitrite can cause a condition which affects the blood's ability to carry oxygen. Infants younger than 6 months of age and pregnant women are more at risk of developing this condition. The presence of elevated nitrite concentrations indicates a pollution event has occurred at the source. Why do we test for total hardness? Hard water is richer in minerals than soft water and tends to have a high content of calcium and magnesium because it has dissolved the compounds present in sedimentary rock. Hard water is safe to drink and is often considered healthy due to its high mineral content. However, there are a number of issues that arise due to the presence of hard water in the home, such as presence of limescale on appliances such as shower heads, hot water heater and dishwashers. Limescale buildup may cause a great deal of damage to appliances and can also affect the water pressure in your home's plumbing system. Soap and shampoo may not lather up easily in the shower and your hair and skin may appear dull or irritated. Hard water may cause eczema and inflame other similar skin conditions. Why do we test for alkalinity? The alkalinity test is a measure of the acid neutralizing capacity of the water. The acidity of the water can erode tooth enamel and metal plumbing in your house. Continued drinking of acidic water can also cause acidosis. Why do we test for manganese? Manganese exceedances in a drinking water supply may point to pollution of the source water, although some exceedances arise from naturally occurring high levels at source. High levels of manganese have also been shown to cause ADHD and learning disabilities. Because of this, it is important to monitor the level of manganese in drinking water to ensure the consumption does not increase to a point where toxic effects may occur. Why do we test for iron? Some older water mains are made from cast iron and may corrode to give the water a rust colour appearance, which may not necessarily pose a health risk, but would not be acceptable in terms of taste or appearance. Why do we test for dissolved solids? Total dissolved solids can affect your water quality, your health, your home, plumbing systems, and even daily tasks such as cooking and cleaning. By measuring your water for total dissolved solids, you can better understand your water quality and how it affects your everyday life, allowing you to make an informed decision to solve your water quality problem and install the most effective filtration system for your home. Why do we test for conductivity? Scientists need to know the exact composition of the water we're testing in order to get accurate, repeatable results. Conductivity in freshwater systems is affected by the geology of the area through which the water flows. Streams that run through granite bedrock will have lower conductivity, while those that flow through limestone and clay soils will have higher values. High readings can also come from industrial pollution or runoff from the roads. Extended dry periods and low flow condition also contributes to higher conductivity readings. Why do we perform a test for Langelier index? The tendency of the water to cause corrosion or scale in pipes and fittings is measured using a useful scale known as the Langelier index. Why do we test for coliforms? Coliform bacteria should not be present in water that is disinfected, and their presence indicates that either disinfection has not been complete, that there is an entry into the water mains in the distribution network, or that the sampling point is contaminated. Their presence in drinking water indicates that disease-causing organisms could be in the water system. Why do we test for E. coli? Certain strains, such as types of E. coli, can cause serious illnesses such as gastroenteritis, dysentery and diarrhea. Exceedances for E. coli can be due to a contamination incident either at the water source or through the water network, for example at a burst mains or at an illegal connection. Exceedances of E. coli can also occur due to a failure in the disinfection treatment process. It is recommended by the EPA that if you have a private water supply, that you test it at least once a year, as private wells are more likely to have a possible contamination.